Colleagues, your contributions are varied a lot, so please do contribute where you can. Let us just do everything with respect and just raise your hand. Um, I'm not sure that Nambane will you be able to check the hands and everything. Maybe we will do it like yesterday. Let Mr. Nambane finish a question and then we deal with a question, that particular question's discussion. So feel free to contribute, colleagues, um, so that we beef up our marking guideline and include all possible questions. Um, I hope you started marking or so that you can see um, uh, any additions. And I hope you also went through the paper yourself and did your own marking guidelines so that you contribute, colleagues. So welcome. And oh, another thing, colleagues, please, even if you maybe leave a meeting because of network problems, when you rejoin, please make sure that your mic is muted because that makes a lot of disturbance. With all that said and done, colleagues, you are welcome and thank you very much for joining us. Ndate Nambane, I think you can continue.
Thank you very much, Mevusi. Colleagues, good morning and welcome to this session of Paper 2, Physical Sciences Memo Discussion. Just a quick reminder, I did share the link to the register in the group, in the chat. And it was also sent to the subject advisors. So we also need registers colleagues. Just as a quick reminder, that is now the only full evidence and full proof that you actually attended this particular meeting. We have realized, let me mute this particular person. Thank you. We have realized, colleagues, that some colleagues watch the videos later on YouTube. Those that cannot be with us now. So please also, if you're going to watch on YouTube, also fill the register later. That is the reason why we are sharing it with our subject advisors. With that being said, colleagues, let me also acknowledge the hard work that went into designing this particular paper. Myself, Mr. Nambane, as the examiner, and Dr. Klein Hans as the moderator, and Mebusi as the quality assurer. Our paper colleagues did not have much of challenges in terms of misprints and so forth. So that is now a bonus for us. But without wasting any time, colleagues, let's quickly look into question 1. Colleagues, on question 1, everything remains as it is. We have not received any inputs, any questions maybe that you feel that needs to be discussed. So question 1, colleagues, it stays now as it is. So it basically says now we will have to go to question 2. So let's quickly go to question 2 and check. If we go to question 2, at 2.1, the information given was consider organic compounds A and B, which have chain isomers and positional isomers respectively. A was given as C4H8 and then B as but2ene. Define the term now positional isomer. That was now at 211, and then it's defined as now compounds with the same molecular formula, 1 mark, but different position of side chain, substituent, or functional group on the parent chain, and then 1 mark. So colleagues, on this one, we have part marking. So just check if now all the underlined words are there. and then you will be able to award a mark. Colleagues, the memorandum you have for 212 where it says now, write down the IUPAC name of the positional isomer of compound B. We added now this yellow option that you see on your screen, which is 1-butene. But we created a criteria for that. So when you see butene, it will be 1 mark, and then 1 mark also for the correct position of the functional group. So if now the learner says only butene, this will only be 1/2. Why 1/2? Because now the criteria here says we also need to check also the position of the functional group. So 1 will be given for just saying butene, but if there is no functional position of the functional group, colleagues, that will be now 1/2. Furthermore, colleagues, let's move now to 2 and 3. Write down the structural formula and the IUPAC name of the chain isomer of compound A. So we wanted the structural formula and the IUPAC name. So for the structural formula, colleagues, the marking criteria is easy. First things first is we check if the functional group is correct. What do we mean by the functional group is correct? We must have a double bond, and the carbon between the double bonds must have a maximum of 4 bonds. Very, very important, colleagues. Immediately after now the correct functional group, the whole structure must be correct. What is the meaning of the whole structure? The number of hydrogens must be correct. All bonds must be there for you to be able to award a mark for the second bullet. So we can only award a mark for the second bullet provided that the whole structure is correct. So if a learner omits an H or a bond, it basically says it will be 1/2. Furthermore, because we asked now for the IUPAC name, colleagues, we check bullet number 1. Bullet number 1 says now you give a mark for identification of a methyl or also the position of the methyl itself. So it will be now 2-methyl or just a methyl, because when you check the structure that we have, colleagues, it basically says we can only have a methyl group at position number 2. So whether the learner says 2-methyl or methyl propene, for that particular identification of the methyl group, we will definitely award a mark. So the name thereof will be 2-methyl, 1 mark, prop 1 in, or methyl propene. But now if the learner obviously says 1-methyl propene, we will not award a mark, colleagues. The reason being, if the learner says 1-methyl, we do not award a mark for that. It is as simple as that. So it will only be 1 mark for the identification of propene only. So that will be now just a 1 mark for the identification of propene. It's very, very important, colleagues, to always try now follow the criteria that is shared with us in the marking guideline. As A to F in the table represent 6 organic molecules. And then the table is given with organic molecules A to F. And then at 2.2, it says now define the term functional group. Colleagues, we do not have part marking here. A bond or an group of atoms that determines the physical and chemical properties of organic compounds. So this will be now a 2 or a 0 kind of a definition. So let's emphasize now that this will be now 2, 2 or 0 for the purpose of marking. So a functional group is defined as a bond or an atom or a group of atoms that determines the physical and chemical properties of a group of organic compounds. So that will now be the 2 or 0 for 2.2.2. Furthermore, it says now at 2.3, write down a letter A to F that represents the following. 231, an alcohol, the correct answer is D. 232, a compound with a 4-mile group, the correct answer is A. And then a functional isomer of compound A, the correct answer is F. And then that is it about 2.3. And then at 2.4, colleagues, it says now write down the IUPAC name of compound C. The criteria, it's straightforward to say 1 mark is given for the correct stem. That means if you see heptane, colleagues, you will give now 1 mark. All substituents bromo, ethyl, and methyl are correctly identified in no particular order, colleagues. If you see bromo, dibromo is there, ethyl is there, methyl is there, you award that mark. Even if the learner decides now maybe to say ethyl and then dibromo, and then the other one is a methyl, the substituents, all of them are correct, even if now the IUPAC name is incorrect. But the fact that ethyl, dibromo, and methyl have been identified, we will give that learner 1 mark. But for us to award the 3rd mark, colleagues, the IUPAC name must be completely correct. That means now including the numbering, the sequence, hyphens, and commas. So the sequence basically says they must be arranged now in an alphabetical order. So if they are not arranged in an alphabetical order, but all the substituents are there, it basically says it will be 2 over 3. I hope the criteria makes it easy for us now to be able to mark this particular question. So it is easy, colleagues. The very first thing that you look for is now the correct stem. You move now into the second bullet where you can easily say, do I have the substituents, all of them there, which will be dibromo, ethyl, methyl, without any particular order. Definitely then it means you can award a mark. For us to award the 3rd mark, it is important for one to be able to say the IUPAC name is completely correct with the numbering, the sequence, hyphens, and commas. At 2.5, it says now compound B and D reacts to form compound E. Write down the name or a formula of the catalyst needed for this reaction. action that takes place, that is esterification, and we will also accept condensation, colleagues. Also be on the lookout, because now most of us are unfamiliar with that, but now condensation we will also accept. 253, it says now, using the condensed structural formula, write down the balanced chemical equation for the formation of compound E. Colleagues, we are going to award a mark for the alcohol and also award a mark for the carboxylic acid. Award a mark now for the ester as well as the product, which is now H2O. Colleagues, the thinking here of the condensed structural formula is we can show the bonds between the carbons, but not the bonds between hydrogen and carbon. So it makes it now to be a condensed structure, provided that we only indicate the bonds between the hydrogen. But once you see a learner now drawing in terms of now another carbon there, CH2, it basically says now this particular thing will no longer be a condensed structural formula, but now a structural formula. So we will not award any mark, colleagues, provided that you are aware that the only bonds that must be shown is the bonds between carbon-carbon, not now carbon-hydrogen. So that's the reason why we said now we can have the or option of those that will prefer to indicate now the bonds between the carbon-carbon atoms, not necessarily indicating the one with now a C and H. So colleagues, just check the first part. It's an alcohol with now one your carboxylic acid, your ester, as well as now your water as a product also. But the key thing here is Nambane, now what if the learner decides now to actually draw a structural formula of water instead of writing H2O? What do we do in that instance? Colleagues, we will have to penalize, unfortunately, but Mebusi will come in once I am done. But the thinking is we will have to penalize, because now the key thing is condensed structural formula. But the condensed structural formula also says we want to see the bonds between carbon-carbon. So maybe this is something that we need now to think of, but where I am is we will now penalize a learner, but we will negotiate and see if Mebusi as our quality assurer can be in a position of accepting that. 2.6. Molar mass of the ester is 60 grams per mole. Use calculations to determine 261, its empirical formula. Colleagues, it is 5 marks. There is no mark for the formula, but we have a mark now for the calculation of this number of moles, for the calculation also of that number of moles, and the calculation thereof of that particular number of moles. So it is basically calculating the number of moles of carbon, number of moles of hydrogen, calculating the number of moles of oxygen. Colleagues, be on the lookout that there is a tick here on 6,6 of the hydrogen. That 6 should actually be the 1 mark for the dividing by the smallest number. So let's move that tick to be here in terms of dividing by the smallest number, which is now 3,3. So that tick must not be there at 6,6167, sorry, but it should actually be for the learner dividing all of them with now the smallest ratio or number, which is now 3,33. So let's just be on the lookout for that. The final mark, colleagues, will be now for the correct formula or for the correct empirical formula, which is CH2H2O. So be on the lookout for that mark that is now at 6.6.7. Colleagues, at 2.6, use calculations to determine its molecular formula. Colleagues, on this one, we are not interested in the calculation of 60 divided by 2. But the learner must somehow indicate that the multiplier in this instance is going to be 2. So even if the learner did not give you this part of 60 divided by 2, but you see there's a 2 somewhere, maybe in an instance where the learner will say 2 multiply or into, let me basically just do it this way, into CH2O. If you see something like this, it basically says you'll give that learner 1 mark, even if you do not see the 60 divided by 30. Then obviously the other mark will be now for writing the complete one, which is CH2H4O2. Then we will give 1 mark for that final answer. So once you see there is a 2, feel free to award a mark. We are not necessarily interested in the 60 divided by 2. Colleagues, that is it with question 2 and the total condensed structural formula at 253 when formula of H2O. Ntatelefera, you are noted. Let me just first give Mebusi for inputs. Mebusi.
Thank you, Dr. Nambane. Firstly, for the benefit of our markers, colleagues, let us ensure that we try to help the learners in terms of answering. In other words, where the correct answer is, let us put the tick. And where the incorrect answer is, let us put a cross. Let us not just put ticks at the end so that learners don't know which part is correct. So let us help a learner in terms of where the correct answer is, or where we want to give a mark. Then we put a tick there. Now, can we go back to 212, Mr. Nambane? Just scroll up.
212. 212.
Yes. As Mr. Nambane said, colleagues, we give, in terms of marking criteria, we give 1 mark for butene. In other words, even if a learner writes but2-ene, which is actually incorrect, but because butene is there, that learner will still receive 1 out of 2. Then the second mark will be gone because the position is incorrect. Hence, the second part says correct position. So the learner will lose the second mark, but will still get 1 mark for but2-ene because of butene. Okay, and then 2.1.3, the one below that one. Colleagues, let us remember the first part says correct functional group. In other words, if we don't have, let me start with this one. For the functional group, we need to ensure that the number of bonds are correct. So even if we see a double bond, but if there are more than 4 bonds for one of the carbons in the functional group, then the functional group becomes incorrect. So the number of bonds must be correct for the functional group as well to give the first mark. And then if the functional group is incorrect, automatically it means the whole structure is incorrect. So some of the learners, for example, will write the structural formula of methyl propane, meaning those learners will get 0 out of 2 because the functional group automatically is incorrect because they are using single. I hope that is clear, colleagues. And then the one of 2.5.3, Mr. Nambane, the water with the bond. Usually we say, in terms of structural formula, whether it is a structural formula, a condensed structural formula, or molecular formula, we usually concentrate on the organic structures. So we penalize for the organic molecules if they are not conforming to the question. But usually for the inorganic molecules or inorganic products or reactants, we don't necessarily penalize. So maybe let us accept even if they show the bonds of water because it's not necessarily an organic compound. So let us give a mark there. But colleagues, when you go back and discuss now, you need to tell your learners that if we say molecular or condensed structural formula, we actually don't need the bonds between the atoms. So they shouldn't give those bonds. And then the last one, Mr. Nambane, 262. Some of the learners might not even show that 2 will give us just the final answer as C2H4. Let us give the 2 marks there because the reason why they got the C2H4O2 is because they multiplied the previous answer in 261 by 2. So if they don't show that 2 at all, they just give us the final answer as C2H4O2. Let us give the 2 marks. Thank you very much.
Thank you very much, Mebusi. Your inputs are always valuable. We have 2 hands. Let me start with Me Altafori.
Good morning, Mr. Nambane and all the other colleagues. I have just 2 questions about what learners do. In 2.2.1, this learner mentions organic compounds, but in the definition for 2.2, he talks of compounds, but he left out the word organic. Does he now get 0, or can we maybe just penalize with a mark, or can we allow? And then my other question.
Sorry, Alta, that is now for 2.2, ne?
Yeah, the definition at 2.2, he leaves out the word organic. Everything is correct, but organic is not there. But he mentioned organic in the first definition.
Okay. Continue. Do you have another one?
Right. My other question is when he writes this condensed structural formula, he puts the OCO in the product in brackets. Do we penalize for that? Or can we allow it? So in the second part, where we get to the product, he writes OCO correctly, the formula is correctly, but he puts that part in brackets. If Mebusi can maybe tell us there what we have to do. Thank you.
Thank you, Alta. CH2. Sorry, colleagues. brackets and then CH2, CH3. But the OCO is in brackets. Mebusi, can we award for that?
In 253, I just had the second part of the OCO that is in brackets, which is perfectly fine. It's fine. We will accept that.
We can award.
Yes, Alda, I didn't hear the first part of 253.
No, there's no second part of the 253. It just says now the learner basically just puts the COO here into brackets also on the carboxylic acid.
It's okay.
It's okay. We
It's
can
okay.
give
Let us
them. Yes.
And then the one
and,
of 2.2.
Yes, if the learner omits the word organic.
Organic. It's fine. Let us allow.
It's fine. We can
give all the marks.
Yes. I think it's clear, Alta. 2-2. We give if the learner omitted the word organic, and that 2-5. What is it? 253 also was discussed in detail. Ntate Lerato Lefera. Ntate Lefera, thank you.
Thank you, Ntate Nambane. I just hope the colleagues do have the what we call the question paper there. When then let us check 213.
213.
Yes, that. The question there says write down the structural formula and the IUPAC name of the chain isomer of compound A. I'm struggling with interpretation of the question because compound A is given as a molecular formula. And then,
yes.
So I don't know whether it's me who's struggling with interpreting the question. So could you please assist?
Okay, let me try and tackle fair. 2.1, it says consider organic compounds A and B, which have chain isomers and positional isomers. Define now the term. Okay, sorry, we are not there. So we are given A as C4H8, and we are also given viewed 2-in at B. So the catch here in Tatelefera was if you draw C4H8, which now must be a positional isomer of A, sorry, of B, it will give you now but 1-ene. So hence the question that follows there is now the structural formula and the IUPAC name, but now of the chain isomer. So for us to create a chain isomer, it means now we must now have a branch thereof. So even if the learner did not draw a structure of but 1-ene for A, it means now, but for one to create a chain isomer, it means they must start now creating a branch. Because now immediately if the learner did not create a branch, it will remain now as but 1-ene. So the thinking here is from the but 1-ene, or even if the learner can draw but 2-ene, the thinking is the chain isomer basically means it must start having a branch in that particular sense. So whichever way you look into it, the chain isomer must have a methyl group. Immediately thereafter, the structural formula also of that must now have the double bond in it. That is the reason why the criteria says correct functional group as well as the whole structure being correct. So the thinking is let learners now have an idea of how to create a chain isomer. Ntate Taitsani, noted Ntate Lefera.
Morning, colleagues.
Morning,
Ntate Nambane, I'm sharing the same sentiments with Ntate Ferrara. Reading 2.1, it says consider organic compound A and B, which have chain isomers and positional isomers, respectively. So the interpretation that we are carrying here is A has a chain isomer and also a positional isomer. B, again, on its own, has a chain isomer and a positional isomer. That's the kind of interpretation that we're having with 2.1. And hence we are struggling to agree on 2.1.3 with the only response given there. Thank you.
But now, Ntate Taetsane, if I may chip in, what other response will be there in terms of 213? Because it's specific to say we are assessing a chain isomer of A.
The issue is here, A is given as a molecular formula. So now we don't know which chain isomer are they referring to. So now we can have a long chain there of C, 4 carbon atoms in a long chain without any branch there. And also one that's indicated there.
Okay, let's do it this way, Ntate Taetsane, because and Ntate Lefera and the colleagues, for purpose of understanding, I stand to be corrected. Let's draw A, colleagues, and A will be 1, 2, 3, 4. And the learner A decides now to draw it in such a way that this is just but 1E. And we have another learner, colleagues, for the very same A who decides now to draw it in a manner of saying, I am going to put now my double bond at carbon number 2, which will be now but 2E. This is also A, colleagues. Now, my question is, if we want now to move to the chain isomer of A, this is A regardless, colleagues. What is it that possibly can happen to this particular structure? The only best way of doing that is to create a chain. How do we create a chain? By making the longest chain, which is now built, a shorter chain. So how do we do that? Colleagues, it will be 1, 2, 3, position of the double bond there, and the CH3 here, colleagues. And then we have 1, 2, 3, 4, 1, 2, 3, 4, and we just have now that, which is the one we have here as 2-methyl propene. Now let's move to this learner who decided that now A is also a but 2E as per the words of Ntate Taetsane and Ntate Lefera. Let's basically check, colleagues. If this is the case, we'll have now 1, 2, 3. Is it now 4? Sorry, 3. Is it now possible, colleagues, for one to say, fine, I am going to have my double bond there or there? Basically, colleagues, will end up now with the same structure in this instance. I stand to be corrected, colleagues. I see hands, I see follow-up questions, but from what I see, basically, that is basically it. I understand that you are also saying, but the C4H8 does not necessarily mean it is a straight chain. I fully agree with you, but the thinking here, colleagues, is even if you move now from 2-methyl not being a straight chain and going back, but now how will that now relate to A and B? I stand to be corrected, and Mebusi, you might just come in there. Let me just allow Marisa to say something, but colleagues, this is the thinking that went into this particular question. Ms. Smith?
Good morning, Mr. Nambane. I would just like to confirm with this question 2.1.3. Seeing as the molecular mass was of the molecular structure was given as then C4H, can the learners then assume that the answer is given as it is given there, the methyl one, the methyl propene, and then assume from there to lengthen then the chain to get to those two A options as you wrote them, the butene, but1-ene and the but2-ene? Or are we not going to accept that?
I lost you somehow, Marisa. Kindly be slower.
Sorry, sir. For question 2.1.3, they asked the chain isomer of A. If I understand correctly, what my colleagues are trying to say is the learners could have assumed that it is already one with the branches, as in the memo. Yeah, and starting from that one and then ending with the longer chain, which will then also be an isomer. Are we then going to?
They start now with the one with branches, and then move to the one that is now a straight chain.
Yes. Are we then going to accept those two or not?
Mebusi, kindly come in.
Colleagues, seeing how you interpret the question, we have no choice but to accept that learners can move from the branched one to the straight chain one. So we'll have to accept if the learner draws a structure of but1-ene, for example, and gives its name, or the structure of but2-ene and gives its name. So we'll accept both. Thank you.
Thank you, Mebusi. We will accept both, colleagues. Your thinking, colleagues, it's somehow complex as teachers, but we appreciate. So Mebusi, maybe I should check. Should we just accept? We don't do an addendum for this one.
I think we will have to put it in an addendum because, I mean, going back to the statement, it shows that, and I can think that C4H8 is a branch. So let us put it in the addendum. And colleagues, let us ensure that if they draw a structure of but1-ene, then the correct name that we give marks will be of but1-ene and the other way around.
Okay. Thank you very much, Marisa. Thank you, Ntate Taitsane. Thank you, Ntate Lefera, for the inputs. This is what we need, colleagues, as inputs, and maybe somehow not having this kind of open-ended questions, but you're thinking it's quite correct. Colleagues, with that being said, I think now Gidibone Jacqueline.
Good morning, everyone.
Morning,
good morning, colleagues. My question is, if a learner drew a wrong structure, but then gave a right name to that structure that they drew, do I give a mark for the IUPAC name and then wrong for the structure that they drew, or it's all wrong? No marks for any of those?
If the IUPAC, we can mark them independently as we have a criteria for the structure and the criteria now for the IUPAC name. So let's not penalize if we only penalize if the structure is wrong, but if the name is somehow correct, I believe you can award a mark. But how will now the structure be incorrect and the weight be correct. So it's something that we need to look into. So let's just ensure that now the structure is also correct, or maybe it is incorrect only because of hydrogen missing or something, but basically let's mark them independently. Thank you very much, Mekidibon. Then, colleagues, let's move to question 3. And on question 3, colleagues, it says now,
Mr. Nambane,
Mebusi,
can Mekidiboni elaborate on the question? Maybe give an example of an incorrect structure, because the IPEC name depends on the structure. So I just want her to elaborate on the incorrect structure that she's talking about.
Okay, I'm referring to Elena just misunderstood the molecular formula altogether and drew butane, for example, or 2-methyl butane. So, and then named the IUPAC as the 2-methyl butane instead of drawing the structure that was required and naming that structure. So the name is correct for what the learner drew, the structural formula that they drew.
Oh.
In that way, make it when that learner won't get any marks at all. Remember, the question talks about the chain isomer, so it must be a correct chain isomer, and then the IUPAC name of that chain isomer. So if the learner, for example, drew a structure of an alkane, then that learner will not get marks at all.
All right, thank you.
Thank you very much, Mebusi. Thank you, Mekidiboni. Ntate Pakatimoyo.
Thank you, Ndade Nambane. My apologies to prolong the debate on this question 2.13. If we go to the statement in the question paper, it says, consider organic compounds A and B, which are chain isomers. Number 1. Number 2, they are positional isomers. So the two compounds, they are both positional and chain isomers. That being said, since B is butene, but2-ene, it goes without saying that A should either be 1 or 3 butene, which makes it that A should in actual fact be branched right from the beginning, because when it is branched, it is an isomer of but2-ene, and it is an isomer due to the double bond no longer being on carbon 2, but being on carbon 1. So in my thinking is, this is the reverse in actual fact of what we are having here. We should be starting with A as branched, and then we are going backwards, in which case then the two answers where we have this one is 2 butene, it cannot be accepted. It will be like B. The one that will be accepted will be this one where it's 1 butene. So the answer we are looking for in actual fact is 1 butene. Thank you.
Thank you very much, Ndate Moyo. We agreed that we'll add that suggestion into the addendum and we will accept. Thank you very much, Ndate Moyo. Mebusi, your hand is still up. Or is an old hand, or it
Sorry
is
about
an old
that.
hand. Thank you very
Yes,
much.
an old hand.
Thank you. Colleagues, let's move to question 3. We have exhausted question 2, and thank you very much for all the inputs thereof. Colleagues, now it says 3 compounds A, B, and C with the molecular formula C5H12 are used to investigate the effect of branching on boiling points. The graph below represents the boiling points of the 3 compounds, A with a boiling point of 36, B with boiling point of 28, and C with boiling point of 10 degrees Celsius. Define the term boiling point at 31 is defined now as the temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. So we usually say, colleagues, if any of the keywords is missing, we award a mark. If everything is in the correct context. In this one, colleagues, if temperature is not there, if vapor pressure is not there, or equals to, basically the whole definition will lose a context. So basically here, let's now make it also a 2 or a 0 definition, because any of the key underlined words, if it's not there, basically everything will lose its context, and it will not be a correct definition for the boiling point. At 3.2, write down the following for this investigation. 321, dependent variable. Dependent variable is a boiling point. 322, independent variable, branching or chain length, we will accept. And then write down the investigative question that is now at 323. And the example we have here, colleagues, it says, what is the relationship between branching or chain length and boiling point? How will the chain length or branching affect the boiling point? The marking criteria, colleagues, says we need to have dependent and independent variables correctly identified. Question about relationship of the independent and dependent, then we can award a mark. But there's this note here which says, if the question can be answered with a yes or no, award 1/2. An example of that will be if a learner says, is boiling point affected by branching or chain length? Branching or chain length. This learner, colleagues, has identified the dependent as well as the independent. But the answer to this particular question is a yes. Boiling point will be affected by branching. So in that instance, this learner will get 1/2. So I hope the part of note is clear. Maybe the learner will just maybe say, will boiling point be affected by branching or chain length? It is a question also, but the answer to that is a yes. Then it basically says that learner will get a 1. So we are interested in terms of the relationship between the independent and the dependent variable. That is the reason why, colleagues, I thought that what will be now the emphasis in terms of the note, if the question can be answered with a yes or a no, award a mark for the correct variables. So that is the reason why we will give now a 1/2. At 324, colleagues, the memo you have, you only have the answer as molecular mass and temperature or molecular formula. We added now these other ones. We added a number of carbons and hydrogens. Very, very, very important. We added also homologous series and functional group. Once we send the addendum, obviously we'll accommodate now the Afrikaans version. So it said now 3.24, write down one controlled variable. That can be molecular mass, temperature, molecular formula, number of carbons and hydrogens. So if the learner just says now number of carbons, it will not be correct. It must be number of carbons and hydrogens, homologous series and the functional group. And then 3.3, it says now, are these compounds saturated or unsaturated? Colleagues, the correct answer is they are saturated. The learner was supposed now to draw the structure of C5H12 as a hint for them to actually identify if we are working with double bonds or we are actually working with single bonds. So for them drawing the correct structure of C5H12, it will definitely indicate that they are unsaturated and they are hydrocarbons, obviously. Then it will basically say it is saturated, and in the memo that you have, it says only single bonds consists. So the correct wording there should be exists. Only single bond exists between carbon atom in their hydrocarbon chain. Or we can also accept there are no multiple bonds between the carbon in their hydrocarbon chain. The issue of negative marking here, I believe it should apply, even though we did not emphasize it, but that is where now we are going to take inputs when we immediately complete this section of question 3. All the hands are noted in the platform will be given immediately once we are done with 3.6. Colleagues, at 3.4, consider compound B. Now write down its condensed structural formula. So the criteria here is basically says first 3 carbons bonded correctly with the correct number of hydrogens. The second bullet or the second mark will be awarded provided that now the last 2 carbons are bonded correctly with a bracket to indicate the branch. So it is important, colleagues, now to realize that it will be 1 mark for CH3, CH2, CH if everything is bonded correctly with the number of hydrogens. The second mark will be given when we have the last 2, that means CH3 and CH3. But the second CH3 must be in bracket to indicate that we have a branch. And anyhow, colleagues, if it's CH2 there, it will mean it basically just a straight chain moving forward. Then we will basically be looking into that. Already the question should be, we are considering B, colleagues. So if we are considering B, it basically says now it must be 2-methyl butane. 2-methyl butane. So when you draw that structure of 2-methyl butane, let's be now on the lookout that we do not shift or move the substituent, which is a methyl, to an incorrect position. It will also be one of the questions that come, because you'll be saying now that CH5H12 was given as a molecular formula, not necessarily a structural formula. So let's be on the lookout that actually A is pentane, because of now a greater or a higher boiling point. And then B will be 2-methyl butane. You need to also to look for that. And then C, because of it having the lowest boiling point, it will have 2,2 dimethyl propane. So be on the lookout for that. Most of us will make a mistake now in 341. Then let's move, colleagues, to three, four, two. 342, it said now, write down the IUPAC name of compound B. The IUPAC name of compound B, colleagues, is 2-methyl butane. 1 mark for butane and 1 mark for 2-methyl. And then we will award a mark for that. Now at 3.5, explain the difference in the boiling points of compound B and C. Refer to the structure, type and strength of the intermolecular forces, and energy for 4 marks. Compound B has a longer chain, less branched, less compact, less spherical, larger surface area than compound C. Colleagues will accept any other one, which basically indicates that compound B has longer chain length, less branch, less compact, less spherical, and it has now larger surface area than compound C. The emphasis here, colleagues, on bullet 2, it's both compound B and C have London forces between molecules. So the learner can maybe start by saying B has London forces and C has London forces. Basically, we will award a mark because it basically indicates that now B and C, both of them have now the London forces. Bullet number 3 will be now the intermolecular forces of compound B are stronger than the intermolecular forces of compound C. So bullet number 3 is comparing the strength of now intermolecular forces. Colleagues, any other word that maybe indicates that intermolecular forces of B are stronger than the intermolecular forces of of C, we will definitely accept. More energy is needed now to overcome the intermolecular forces of compound B. If the learner says more energy is needed to break the bonds, colleagues, we do not accept. Because the strength that we are referring to is the strength of the intermolecular forces as referred to bullet number 3. So if the learner uses now break the bonds, that will be an incorrect science. So when we go back and give feedback to these learners, let's emphasize that more energy is needed to overcome the intermolecular forces, not necessarily to break the bonds. This learner was referring now to compound B, but we might also have learners, colleagues, who will refer to compound C. So compound C will just be an opposite now of compound B. Then this will just be compound C has a shorter chain, more branched, more compact, more spherical, smaller surface area than compound B, and both B and C have London forces between the molecules. The intermolecular forces of compound C are weaker than the intermolecular forces of compound B, and less energy is needed to overcome the intermolecular forces of compound compound C. And then at 3.6, which compound A, B, or C has the highest vapor pressure? Give a reason for your answer. The correct answer there is C, because now it has the lowest boiling point. Colleagues, we will also accept that C, it has now weaker intermolecular forces. Then that will give us now a total of 19, and that will be question 3. Colleagues, inputs and comments, please. I don't see any hands. It says here at 341. Can you also accept? Let me maybe write it down also for this for the colleagues to actually see what you are referring to. It's Charlotte. 341. Charlotte is saying, colleagues, can you accept CH3? CH into CH3, CH2, CH3. If I am getting it right. Colleagues, let's look into this option. Let's look into this option. I am tempted to draw the structure, but this will basically says now the learner actually drew a structure and identified that the CH3 will also be at carbon number 2. But let's check the criteria thereof. The criteria now says the first 3 carbons bonded correctly with the correct number of hydrogens. In this instance, which ones will be the first 3? The first 3 in this instance now should basically be CH2, CH3, and another CH. So they are actually identified correctly. So this here should be now the first mark. The second mark will be, it is still now at CH3 or at carbon number 2, then with the correct CH3 and another CH3, then it's easy for us to award a mark, because if you draw that particular structure, you will still get 2-methyl butane from where I am, but we will verify and check, but I think that will now be the case. And the other question in the chat is for consistency through grade 10 to 12, which we do not have through our documents. I suggest we accept temperature as a substance. Let me check. We accept temperature of a substance in the place of a liquid as grade 12 exam guidelines, May 2021. That is now for 3.1. Let's maybe quickly check what is the actual definition, or what is it that we have in our terms and definitions. In our terms and definitions, what we have is boiling point is defined as the temperature at which the vapor pressure of a liquid equals to the atmospheric pressure. That is now at 3.1, and that is for circuit 4. I am here. The temperature at which vapor pressure of a liquid is equals to the atmospheric pressure. It basically says, can we also, sorry colleagues, I'm using 2 monitors so that somewhere I can read the inputs and also write on the other screen. It basically says now, for consistency through grade 10 to 12, which we have through our documents, I suggest that we accept temperature of a substance. I want to put my head on the block and say, let's not accept, because now this is now the only definition that is accepted at the end of the year as per the CAPS document. So we are not going to accept if the learner says the temperature of which the vapor pressure of a substance. We will not accept that as per terms and definitions, as per the exam guideline itself. So it will only now be in a sense that the liquid is the vapor pressure of a liquid is equals to the atmospheric pressure. I stand to be corrected. For question 3.2, is surface area acceptable? Let me quickly go to 3.22. And we're identifying an independent variable. Stan Joy is asking if we can be able to accept surface area. Joy, for that one, I will maybe give it to Mebusi. But the fact that here on 3.5, we are saying compound B has longer chain length, less branches, less compact, less spherical, and larger surface area. I believe now we can also accept surface area at 322, because now we are going to accept it when they explain in terms of the difference in boiling points. So the thinking is maybe we should accept, but I will open up to Mebusi also to comment on that. Ntate Taitsani.
Morning, colleague, once again.
Morning, Tati.
I'm referring to question number 323, 3.2.3.
3.2.3, investigative question.
Investigative question. If we will not be able to accept the following as an option, what is the effect of branching or chain length on boiling point? What is the effect of branching or chain length on boiling point? Question mark. Thank you, Ndati.
Thank you, Ntate Taitsani. What is the effect of branching or chain length on boiling point? Then question mark. Dependent variable, independent variable identified. I think that should be 2 marks. Mebusi, kindly come in before I go to circuit 3 for any inputs maybe that you might have on question 3.
Thank you, Ntate Nambane. The first one that I remember now is 322, whether we can accept surface area or not. I agree, let us accept surface area, it is correct. And the one of Ntate Taitsani right now of the investigative question, that is perfectly correct as well, 2 marks. The one of 3.2.4, the one that you said learners need to mention both the number of carbon atoms and hydrogens. Kindly underline everything, number of carbon atoms and hydrogen, so that colleagues can remember. and make "and" as the capital letter for that one. Those are the questions that I remember. Any other questions that I remember?
Let's go to this one of 3.3. Should we apply negative marking? Because now the correct answer is saturated, and obviously the reasoning should support the choice of the answer.
Yes, 3.3, and the last question is 3.6. We need to apply negative marking.
So let me quickly say, colleagues, here we are going to have now negative marking, because obviously the learner cannot say saturated and say only single bonds. So that will be incorrect science. So let's have negative marking. And then the other one is 3.6. We will also have now negative marking on this one. Let me just do it this way, and we'll also have negative marking. Second 3 schools, kindly open up your mic and let's hear what you have to say on question 3.
All right, thank you, Ntate Nambane. A question there I know you have said under correction and you're waiting for Mebusi. Maybe she forgot to refer to it. But as it stands in the examination guideline, where you see the liquid 3.1 in Tate, we are coming back for it. We're coming back for it. So in the examination guideline as it stands today, it still has there where you see the liquid stands substance. I do understand we have these documents. We need to have harmony through all of them, because every time from the subject advisors is we must use the examination guideline. So as it stands in the examination guideline, I beg that we consider where we see the word liquid, we consider the substance as well. If we need to change it, let's change it on documents, all of them.
Okay.
And
lastly, okay, or you have another one that the Twinsie?
On the platform in Matla. Also, if we go to that, you're standing right at 3.2.2. I'm a little bit worried, though maybe the argument might be thin, but this is what we teach from grade 8. The learners, every time when they are given the graphs, they would refer to the horizontal axis, meaning the x-axis, to see their independent variable. And on this particular graph that is given, they see a compound. So I'm afraid we might be seeing that word compound quite often when we mark for 3.2.2 as the independent variable. That's my input. So please, let's also maybe discuss it.
Oh, okay. Thank you, Ntate Tunzi. Mama Busi, let's start with this word, liquid being substituted with substance.
Colleagues, for the definition, can I go back to my memorandum? Usually we have a look at the temperature at which vapor pressure equals the atmospheric pressure. The part of a substance or of a liquid or of what, we can put that one in brackets. Ne? The most important words are temperature at which the vapor pressure equals atmospheric pressure. So those two, those words are important. And in terms of changing documents, examination guideline, colleagues, is a national document. So that comes from national. We can't change anything until they revise it and give us a new one. So we can't change anything. Hence, most of the time we'll put the word of substance in brackets. So Ntate Nambane kindly put the of liquid in the brackets. and then underline the other words.
Okay.
The part of
3.22. 3.2.3. 3.2.2. If Elena says compound as independent variable from using the graph where we know that where y will represent dependent and then x will represent the independent variable.
Colleagues, let us not accept that one. I understand the part of the graph saying we usually plot on the x-axis the independent variable, but it is important also for the independent variable to be specific. So if they just say compound, it's not specific. So let us not accept that one. Let us ensure that they know in this case, as the statement saying, we are investigating the branching of those compounds. So the most important part is branching. So let us not accept compound, colleagues.
Thank you very much. Mebusi, I don't see any hands or comments in the chat. It basically says we have exhausted anything or any possible answers in question 3, colleagues. Without wasting any time, let's go to question 4. Colleagues, question 4, I don't know what to say. I must just say maybe it's going to be challenging for learners, but for the purpose of going back and giving feedback, because one of the most challenging issues we have is when the learners have written an exam or a control test, we don't actually discuss the memo with them or the findings or the mistakes that they actually do. What we do is we give them a copy of memorandum, and that does not assist. They rewrite the memorandum in certain schools. But do we actually go into the actual reteaching of the topics? Why am I saying this? When you look into the question itself, it's not your standard way of questions that are usually used in organic reactions. It says, consider the following reactions 1 to 6 involving compounds A to F. Molecules represented by the same letter are the same in all reactions. So when you see A in reaction 1, in reaction 3, in reaction 4, in reaction 6, it basically says it's the same compound throughout. But what are we teaching them in school? We are teaching them that you must basically find where the double bond is. Because once you are able to identify where the double bond is, it will become easy for one to be able to identify types of reactions that will occur there. Colleagues, learners will not necessarily expected. The train of thought here will be for them to be able to answer all questions that are going to follow. The hint was given at reaction 6. So reaction 6 was 2-bromobutane, giving us A plus NABR plus E. Colleagues, that reaction is now dehydrohalogenation, which basically means now we are going to have A as a double bond and we are going to have E as water. If they were able to identify reaction 6, colleagues, all these other ones are going to be easy. So I may be tempted to say I will put now a complete reaction 6 as part of this. But now, before they actually answer the question, it was best for them now to actually go into reaction 6 and identify the double bond. So maybe when we go back, let's go and emphasize the approach of now what we call the RCP, the reactants, the product, as well as the conditions of this particular reactions. Colleagues, with that being said, at 4.1, it says, write down the type of reaction represented by the following. 411, the answer is substitution, 1 mark. 412, reaction 5, it's combustion, because we have now O2 reacting with D. And then now at 4.2, consider reaction 1 to 6. To which homologous series does compound A belong to? It belongs to alkane, colleagues. Hence, I said it was best for them to identify what is A. If it is identified, then everything falls into place. 422, it says now, write down the structural formula of compound A. So this was going to be easy, provided it is identified now from reaction 6. Reaction 6 was actually the one that will give this. But because we did not ask colleagues for major product or minor product, we are going to accept this one as the major product. Sorry, colleagues. We are going to accept this one as a major product. And we are going to accept this one also as a minor product. Because initially we had a major product only. But yesterday when we went through the paper also, we realized that whether the learner gives us a major product or a minor product, it will not necessarily influence all other reactions. So we are going to accept a major product or a minor product, colleagues. So the first thing is correct functional group. That means now the carbons here should have 4 bonds and the double bond. The whole structure should be correct with hydrogens. If there's any other missing hydrogen anywhere, then it means we will be able to award 2 marks. So the memo you have, colleagues, you do not have this part of the minor product. So we are going to accept the minor product and basically apply now the same marking criteria. The correct functional group with 4 bonds between the carbons, as well as now the whole structure being correct with the correct bonds, as well as the number of hydrogens. Now at 431, consider the reaction 2, write down the name or a formula of compound C. And the name or formula of compound C is HBr, or hydrogen bromide. So we are going to accept that. 432, CN H2N plus 1X. That is now the general formula of 2-bromobutane. That will also be 1 mark. Now 4.4, it says now reaction 3 is an elimination reaction. Use the structural formula to write down the balanced equation for this reaction. Indicate one reaction condition above the arrow. The marking criteria is also there, colleagues. It says the whole structure for structural formula of compound B is correct. The whole structure, colleagues. Why do we want it to be the whole structure? The reason for that is B from reaction A will only be butane 2-ol. That is the only one that we can have. Then the expectation is it must be now the whole structure correct. That means now we only award a mark provided we have the correct functional group and everything, the bonds, the number of hydrogens, as well as now the number of carbons, is then that you can award this 1 mark. The second mark is reaction condition H2SO4 or H3PO4 or heat. Colleagues, for any one of the 3. If you see H2SO4, you can award a mark. If you see H3PO4, you can award a mark. If you don't see H2SO4 or H3PO4 and you see heat, you can give a mark. That will be now bullet number 2. For bullet number 3, the functional group of the alkene. The functional group, colleagues. Maybe I should have placed this mark here to say it's actually for the functional group. So if the functional group is a double bond, and how do we confirm that? C and C double bond, and now each carbon must have a maximum of 4 bonds. Then lastly, the whole structure of now the alkene is correct. That means now the other mark will be for the whole structure being correct with the number of carbons, the number of hydrogens, and all bonds. The last mark will be now for the H2, the H2O. Whether it is going to be a structural formula of H2O, you can just give a mark. Whether it is now the molecular formula in this instance, you can just now award a mark. Then that is the criteria for 4.4. Let's quickly now go to question 4.5. At 4.5, it says now, consider reaction 4. 4.51, write down the name or the formula of the catalyst needed for this reaction. So it is PT, PD, or Ni, or a learner can just give us now the names of that, platinum, palladium, or nickel for 1 mark. Compound D is known as a hydrocarbon. Define the term hydrocarbon. Hydrocarbon is defined now as organic compounds that consist only of hydrogen and carbon. Colleagues, this also will be now a 2 or 0. Even if the word organic is not there, I think we can also accept if they say now compounds or consists of hydrogen and carbon only. That is very, very important. At 4.6, write down the names and formulas of compound E and F. So from reaction E, colleagues, it is oxidation or combustion for that matter. Then it basically says the products there, E must be water and F must be carbon dioxide. But now, colleagues, our learners tend to do this. A learner will write E and say it is CO2, and write F and say it's water, or H2O for that matter. Colleagues, will not give a mark for that. Why not give a mark? Because the learner has committed that I am referring to E as carbon dioxide, which is not correct. Because if we now say E is carbon dioxide, when we check now reaction 6, when we check reaction 3, when we check reaction 2, it will not now be okay for us to say E is actually carbon dioxide. So, but now if the learner did not commit and you see something like H2O and then something like water, colleagues, you can award a mark because the learner did not commit. So we do not know whether the learner is referring to H2O as E as a F or H2O as E, but because the learner did not commit, then we will not, we will accept and give 2 marks. But once the learner commits, colleagues, to say E is CO2, definitely we will not now give a mark. Immediately, if the learner says F is water, definitely we will not give a mark. At 4.7, colleagues, it says now for reaction 6, write down 2 reaction conditions. Colleagues, it was easy for learners to pick one of their conditions because we actually gave them that the product will be NaBr. So obviously they will know that we are actually having a base. But now, what kind of a base? It must be concentrated strong base. So if you do not see the word concentrated strong base, you cannot award a mark. Then the second one will be heat. So with that being said, colleagues, that's basically it with question 4, and the total of question 4 is 19 marks. Before I take hands, maybe I should just say in previously we would accept if a learner here says now oxidation, because anyhow that is how we have it in all our documents. I don't see any hands, colleagues. Maybe let me go quickly into the chat. May I be allowed to retract my input above for the reason I interpreted the question wrongly? Compound A has a chain. Okay, that is now for question 2. We are not there, that Moyo as yet. And then Charlotte says, now, can we accept oxidation? Charlotte, I believe we can accept oxidation. Mebusi will maybe check if we can. And then can we 432? What if the learner writes 432? Let me quickly go to 432, colleagues. Is this one here? If the learner says CnH2n plus 1 Br, I am tempted not to give, but I will ask Mebusi. I am tempted not to give because now, what if it's Cl in the near future? What is iodine? What if it's fluorine? It doesn't necessarily say that is the general formula, but maybe you will emphasize that, because the general formula basically means it should not represent a specific haloalkane. It should be now general for all other halogens that we may substitute or have. Mebusi, inputs please on this particular one.
Thank you, colleagues. For 4.3.2, if Elena says CnH2n plus 1 Br, let us give the learner a mark, because the learner shows that he or she knows the how to get the general formula, but just emphasize that it actually needs to represent all haloalkanes, not just this particular one. But because the other things are correct, and let us give that 1 mark.
Thank you very much.
Was it the only?
That is the only one that I have. Maybe emphasize on 4.7 also, maybe see if
4.7, Dr. Nambane, I want us to remove the KOH and LIOH option because the product is NABR. So if we include KOH and LIOH, then the product of the inorganic reactant product that is given there will not be correct. So let us remove KOH and LIOH. And even if the learner gives NaOH, colleagues, it is important to say concentrated NaOH, not just NaOH. Thank you, Dr. Nambane.
Thank you very much, Nebusi. So colleagues, at 4.7, we scratch out KOH and lithium hydroxide because the product it's NABR. Colleagues, I don't see any inputs. I don't see any comments. That basically says it is an indication now that you are happy with everything on question 4. Colleagues, question 5. The graph below represents a reversible reaction and shows the changes in potential energy for the reaction. Colleagues, I must say, when you look into the Afrikaans version, that X is sitting exactly at 40 kilojoules per mole. But now when you check the one of Afrikaans, there's the English, sorry, there's a slight change. It's sitting somewhere above now the 40. So for that, we created a range. You will see when we start now discussing to accommodate both now Afrikaans and English version. So the very first one, it says now, define the term activation energy. So activation energy is defined as the minimum energy needed for a reaction to take place. Now that is now also 2 or 0, colleagues. 4.3, write down the value of X. Colleagues, because of that shift, we initially had the answer as 40. So for that shift now in the graph, we are going to accept anything between 40 to 43. Why not 44 or 45? Colleagues, even if there's a shift, it's very close now to 40. It will not go beyond the 45 if you check now the dimensions of between 40 and 50. So we will accept anything, colleagues, that is now between 40 and 43. Write down the name of an unstable transition state represented by letter Y, that is activated complex, 1 mark. 5.4, calculate now the activation energy for the reverse reaction. So for the reverse reaction, colleagues, now if the learner at 5.2 says X is 41, colleagues, it will mean we expect to see a substitution of 41 here. If the learner said now this is also 41, then that will mean now it will be 41 plus 50, that will give us 91. So let's just ensure that when we award this mark, it's actually the mark of the substitution or the answer at 5.2 must relate with the answer here or the substitution at 5.4. Then we will be able to say the answer that the learner will get will fall into this range of 90 to 93 kilojoules per mole. Very, very much important. You are noted, Mesilo, you will be given a platform once we are done with this particular question. And at 5.5, colleagues, it says now calculate the heat of reaction for the reverse reaction. That is now 5.5. Colleagues, there is no mark for the formula, but there is a mark for the substitution of 10. On this one, we do not have a problem because when you check the graph, it basically says for the reverse reaction, my 10 now is going to become my product, and my reactants are now going to be the one with the negative 50. So it is important, colleagues, to understand that this one, it stays as it is, but now the emphasis is also in us giving the mark here for the 50, it must be negative 50. And we will award a mark now for the final answer. At 5.6, it says now, is the reverse reaction endothermic or exothermic? It is, colleagues, endothermic. The reason for that is energy is absorbed or gained. Delta H is greater than 0. One will now maybe add something like energy of the products is higher than energy of the reactants, something like that. I think we will also accept. Colleagues, with that being said, that is now the end of question 5. Comments, inputs, questions will be readily taken. Mesilo. Mesilo, your hand is up. Kindly unmute and ask your question, please.
Ntate, morning. Can I take you
Morning,
back to 4.1.1? 4.1.1. If the learner have written hydrohalogenation.
4.1.1.
Hydrohalogenation.
Is hydrohalogenation a substitution reaction, ma'am? It is not. It is
It's
an
a type
addition.
of
Is it a type of substitution?
yes. Hydrohalogenation.
Hydrohalogenation.
Yeah.
May we see?
It's Memutau.
Memutau. Hey, I can hear your voice, Memutau. Memutau, in 411, we will not accept hydrohalogenation. Hydrohalogenation is an addition reaction, Memutau. So for that substitution reaction, we only have substitution reaction. We don't accept anything.
Okay. Okay, thank you.
Thank you, Memutau. Nambane, can I comment on question 5?
Yes, ma'am. I'm going there.
In 5.2.
5.2. Yes.
Just to emphasize the unit that is in brackets, because 5.2, the unit is in brackets, you accept if the learner just gives the numerical answer without giving the unit. So 41, 42, 43, 40 will be fine without a unit. But in 5.4, Nambane, when you do the addendum, please include positive marking. at the top, it should be positive marking from 5.2. Now, colleagues, for 5.4, it is important that the final answer must have units because they are calculating there. So the unit must be there. And then 5.5, because of the shifting in the Africans graph, we will have to include a range there. I think we can see the range is from 60 to 63 kilojoules per mole, just to allocate or to accommodate the shifting there, colleagues. And colleagues, I'd like to take this opportunity to apologize for you in terms of the shifting. The original paper have the values, hence we have those dotted lines. They are exactly on 10, for example, and then on 40 there in the positive axis, and then on minus 50 there in the negative axis. But when exams do the editing, unfortunately, there was shifting there. So yeah, apologies for that one, colleagues.
Thank you very much, Mebusi Mokwena. Kindly unmute. Mokwena. Okay, let's go back to Silo.
Hello, Ntate Nambane.
Hello, Ntate.
Yeah, actually, I'm sorry to take you back, to question.
Yes, question.
Yes.
We are losing you, Ntate Mokwena. Question.
Yes, Ntate Nambane. I'm sorry for taking you back to the question that we have passed. That is question 2.5.3 there.
Ntate Mokwena, can maybe let's pause it because that one is somehow very far. Let's pause it, and then maybe towards the end we will go back to it.
All right.
Yeah, no, let's pause it, Menir, such that now we don't go too far in terms of the discussion. Then towards the end, maybe we can just do general questions, then refer to them.
All right, no, that's fine.
No, thank you very much, Menir. Colleagues, let's go to question 6. I don't see anything on the chat, as well as the hands. So let's quickly now go to question 6. Question 6, colleagues, it says now 10 grams of calcium carbonate reacts with 20 centimeter cubed of dilute hydrochloric acid with a concentration of 0.05 mole per decimeter cubed. Calcium carbonate is in excess, and now the diagram below represents an Erlenmeyer flask connected to the syringe, and the gas is collected now in the syringe. The balanced chemical equation is given, and the diagram is there also at 6.1. Colleagues, it says define the term rate of reaction. Rate of reaction is defined now as change in concentration, amount, and the number of moles, volume or mass, 1 mark, of reactants per time or per unit time. Colleagues, if the learner is going to use that definition, we are going to give or to have part marking. The first mark will be for saying change in number of moles, or change in concentration, change in amount, or change in mass. The second mark will be for saying per unit time, but the unit now is in brackets. If the unit is in brackets, it basically now says, even if it's not there, colleagues, we can award a mark. Bullet number 2, or option number 2, is the amount of moles, volume, or mass of products formed or reactants used. So colleagues, if they refer to the amount of products, the weight formed must be there. If they refer now to the reactants, the weight used must also be there. It's very, very important. So for us now to award that mark, let's now check if all the underlined keywords are there. Colleagues, there's this other one that says now rate of change in concentration, amount or of moles, number of moles, volume or mass. Because the learner is using the word rate, colleagues, everything should be correct. Then that one we will make it now 2, 2 or 0. It is very, very important for us to do so. Moving along, at 6.2, how will each of the following changes in conditions affect the rate of reaction? Calcium carbonate is replaced with calcium carbonate powder is replaced with calcium carbonate lumps, that will decrease. 622, the temperature of HCl is increased, the rate of reaction will also increase. And then 623, it says now use the collision theory to explain the answer to question 6.22 for 3 marks. Colleagues, bullet number 1 says now increase in temperature, because we told them in 6.22 that the temperature of HCl is increased. So we are not expecting a learner to give a reason in terms of a decrease in temperature, because the actual factor that was changed, or the condition that was changed, is now increase in temperature of HCl. So increase in temperature increases the average kinetic energy of the particles. In most cases, other people use the word overall kinetic energy of the particles. More particles will have sufficient kinetic energy, which is now greater or equals to the activation energy. More effective collisions per unit time, or the frequency of effective collisions increases. Colleagues, all the underlined words must be there. One also must say the kinetic energy must be greater or equals to the activation energy. Very, very important. Increase in temperature increases the overall kinetic energy of the particles, or particles will move faster. That is now at 6.23. Very easy to mark. Just focus now on all the underlined words must be there. If a learner says more collisions per unit time, you will not award a mark. The word effective collision should be there as per important words of the collision theory. 6.3, colleagues. The graph below represents the Maxwell-Boltzmann distribution curve for the above experiment. The graph is given, and then what is represented by the following letters in the graph 6.3, A will be activation energy, 1 mark. B will be the number of particles with sufficient kinetic energy or enough kinetic energy. So colleagues, the key word here is the number of particles. If a learner says particles with sufficient energy, I think we will also accept, but the challenge will be when we move into the graph also, we will have now to see how we can go about that. How will A shift when a catalyst is added? Choose from shifts to the left or shifts to the right. The correct answer, colleagues, here is shifts to the left, 1 mark. Now, the memo you have, colleagues, is the initial memo we distributed now to you and to the subject advisors. But we found that we actually changed the question. We changed the question because it was referring to a catalyst. And if you check the question of now 6.33 also refers to a catalyst. So we actually said, but let's remove this and focus now on the effect of temperature thereof in terms of the Maxwell-Boltzmann distribution curve. Redraw the above graph in your answer book and clearly indicate the following. How will A and B change if the temperature is increased? So if we increase the temperature, colleagues, curve at higher temperature has a lower peak and shifted to the right of the original curve. So I am going to identify, sorry, colleagues, I am going to identify to say now this one is actually the original curve. And this one here is actually the one with now higher temperature. Bullet number 2, or for us to award a mark, curve at higher temperature has now a larger area at B. That now will be for this particular section here to say we actually have now an increased area under B. That is when we can award the second mark. So this will be now at higher temperature. Very, very important, colleagues, for us to look into that. So remember, you will get this memo, no problem. But while we wait for the addendum later today, let's now have this information for the purpose of marking. And then at 6.4, we have a marking criteria, colleagues, because the question said now calculate the average rate at which calcium carbonate reacts in grams per second. HCl is used up in 1,3 seconds. The criteria, colleagues, will be to say 1 mark for the formula C is equals to N over V, or N is equals to M over the molar mass. That will be your 1 mark. The second mark is the substitution of 20 multiplied by 10 to power negative 3 in the equation, it must be in that equation, colleagues, which is C is equals to N over V. And then the using of the molar ratio, colleagues, to say 1:2, but they must actually use, hence the word using, it's now capitalized and bold. It's actually the using. So if you don't see an application of 1:2, we do not award a mark. Then we have bullet number 4, the substitution of 100 grams per mole in this particular equation of N is equals to M over M. Calculating now the final mass, we will award a mark. Correct substitution into the rate equation, and the final mark now for 0.038 grams per second. Colleagues, let's look into this particular option. For either C is equals to N over V or N is equals to M over M, for any one of those, we will award 1 mark. Bullet number 2, the substitution of 20 multiplied by 10 to negative 3. And now the bullet number 3, let me make this one 1 for the purpose of marking, colleagues. Bullet number 2, that one there, 20 multiplied by 10 to negative 3. The use of the ratio, then that will be now mark number 3. Sorry, colleagues. That will be now mark number 3. And now the substitution of 100, that is mark number 4. We don't give a mark, colleagues, for the mass of calcium carbonate reacted, because now we are interested in the change. Then that is the reason why we want to give now this mark to 9.95. So we have a mark number 5 here, which is for 9.5 minus 10, and the other mark, which is now at 6, will be for the whole substitution, the correct substitution. And note, colleagues, the negative must also be there. Why? Because we are working with a reactant. So the actual mass of the reactants is decreasing. So we cannot have a rate of reaction that is negative. So the note that the negative must also now be there. It is very, very important. Then the final mark must be 1 mark. Then this will be our 7 marks. Note that the SI unit is in brackets. Why is it in bracket? Because the question said now, calculate the average rate at which calcium carbonate reacts in grams per second. So the SI unit was already given. Colleagues, let's teach the correct science. In an instance where the learner says now rate is equals to 0.05 divided by 1.3 is equals to 0.3, okay, 0.38 grams per second. Colleagues, we are going to penalize 1 mark for that. Why? Because the equation says it must be a change in mass. And the 0.5 here, it does not indicate that particular change we are interested in. So we are going to penalize 1 mark, then that means this learner will get now 6 over 7. Why? Because 0.5 does not indicate the change in mass. So because of that, we can only penalize this learner once. But now when we go back and teach, let's now emphasize as per definition that now it is now change in mass per unit time. So the changing part is what we will usually say it is your final minus the initial. The indication of 0 must also be there to indicate that actually the reaction now started from the beginning until it reached now completion. Colleagues, with that being said, that is it now with question. No, it's not it with question. No, it is it with question 6, and the total of question 6 is 19 marks. Colleagues, inputs, please. Mr. Taitsani.
Ntate Nambane, can we please go back to question number 6.3.4?
6.3.4. This one here, the graph.
Yes, sir.
Yes,
let's read the instruction and question together. It says, redraw the above graph in your answer book and clearly indicate the following. And then the question says how A and B will change if temperature is increased. As a learner, I'm looking at the graph I've just redrawn. I see A represents the line for the activation energy. And then B representing the number of particles with sufficient kinetic energy. Now I need to respond to this question. It says, how will A and B change if temperature is increased? A representing the activation energy will stay the same. B will increase. Thank you, sir. So the response
100%.
that I will give there as a learner, I will say A stays the same, B increases. I will not be redrawing the graph. Sir?
But it says redraw the above graph and clearly indicate how will A and B change. So in that graph that they draw, they don't necessarily have to draw the original. I added the original for the purpose of emphasis. They don't necessarily need to draw the original against now the one of the temperature being increased. All that we wanted is the shift, but A obviously remains the same, and there's an increase now in the number of particles under the area of B. So the only thing that we want is to show the shift as well as A becoming now the same and the area under B now increasing. They don't have to redraw the original, but now the redrawing part basically says they must indicate how A and B will be affected.
Ntate Nambane, I hear you. I think the intention was drawing the graph of the temperature when the temperature is increased. But the way the question is phrased is referring to the redrawing of the graph. And redraw means I must reproduce what was originally there, which is the graph in 6.3. I'm redrawing it as it is. And now I must clearly indicate A which is the line for the activation energy, that will not change as the first response. And then B, when the temperature increases, I know that area B will increase. According to the graph that you have shown there, it even shows clearly for all of us that the area B has increased. That is why I'm saying line B, representing activation energy, will stay the same and B will increase. Thank you, sir.
Thank you.
Let's have a look at how the question was.
Okay, noted. That is Taitsani. Thank you for the inputs. Let me take, maybe you are also noted, Velin Hlapo.
Good morning.
Good morning, Tate.
Yes, sir.
We are with you, sir. Yeah.
Yes. Question 6.4.
6.4. Let me quickly go there, sir. 6.4. Yes, sir.
Yes, I am asking, as an option, will a learner be allowed to work out the rate using hydrochloric acid and only convert at the end using the ratios?
That will be incorrect science, because remember, we can only now compare a mole ratio in terms of the number of moles, not necessarily the rate of reaction. Then also the question is clear to say calculate the rate of the calcium carbonate. So I don't think we will accept, unless I'm missing something else, but yes, maybe explain further, say.
Yes, what I'm saying is, if I calculated the rate of the reaction using hydrochloric acid, I will end up with something like 0.028 grams per second. Then using the ratios, I can still get that 0.038 for calcium carbonate.
Can I maybe just say, send that option to your subject advisor, because the tricky part will be also the allocation of marks thereof. So I don't want now to necessarily commit to it without the actual answer of the learner. Maybe you can just take a picture of it now, send it to this particular group. I will be able to download and maybe look into it quickly, because my concern now will be, if that is the case, it will also influence the marking criteria.
Okay.
Yes, so let's have the answer, and in the chat it will allow you to send a picture, and then we'll interrogate it further with Mebusi and the team that went into this particular paper. Thank you very much. And Tate Taitsani, you are noted. Before Tate Taitsani, let me give Mebusi an opportunity to explain now at 634.
Thank you, colleagues. 6.3.4, if a learner writes A remains the same, it will be a mark. And then B increases, it will be a mark as well, because the learner will be following the instructions and answering the questions as it was asked. So those 2 marks will be awarded. And then
sorry, A remains the same. Sorry, Mama Busi, let me just capture that. A remains the same. One mark, and B increases, even if they do not draw the graph, Mebus.
Even if they don't draw the graph, or they redraw the original graph and write those comments on that graph, that will be fine.
Okay, 100%. A remains the same, B increases. We will accept.
Area B increases. We accept. And then can we go back to the 6.1?
6.1. 6.1. Yes, it will show now.
Just underline in bullet 2. Please underline formed as well as used, because we need to show that change. Ne? So the amount of moles formed, that's a mark, or the amount of moles used, that's a mark, because that indicates the change. So the learner cannot just say amount of moles per unit time. It says amount of moles formed or amount of moles used. Even without the products and reactants, it's fine.
And the other one will be 4 per unit time.
Yes.
Okay. That's all you have, Mebusi?
I think that's all I have. We'll wait for the option of that last question, but it actually will be correct. But we'll wait for that option so that we can allocate the marks. We do have
the marks accordingly.
The ratios in terms of rate.
Yeah, I also thought so. Hence, the thinking was let's have the question or the answer and maybe allocate marks accordingly. And that TW Mukwena, that Veli Nhlapho, is it an old hand or a new question?
That Nambane, sorry. Can I come in?
Tate Mukwena, come in, Tate, please.
Good morning, Tate Nambane.
Morning, sir.
Can we please go back to that graph, Tate? Because I was hoping something will be addressed here, but I think it has been left like that. 6.3.4.
Yes, Tate Mukwena.
The question raised by Tate. Yeah, by Tate Taizan. Because now we must then go back and address the marking criteria. That if the learner has drawn a graph without the comments, if a graph is drawn, how are we going to mark that graph? We cannot go with the same marking criteria now, because the learner must get the mark for A, staying where it is. Yeah. Do you get me, Mr. Nambane?
I follow that team.
Yes, the second bullet is correct for that mark where the temperature is higher, larger area at B. But the mark for A remains the same. That's where I have a concern.
100% in the Mukwena. Hence, when I do the addendum, obviously, because now if we are going to award a mark for A remains the same, it should also be part of the marking criteria. So that will also be considered, and it will definitely change Minir. So that we have now a standard way of answering 634. Ndate Nhlapho, is it an old hand or a new hand, Minir?
It's an old hand.
I guess. Let me just lower it for you then, Minir. Lower that Nhlapho's hand, lowered. Colleagues, I don't have or see any inputs. Maybe let me quickly check on the chat. Okay, the answer question is there, large. Charlotte, we will give 2 marks for the picture that you sent, because A remains the same and then B is now larger. Definitely we will give 2 marks for that. 3-4, if there are no labels, can a learner be awarded for a lower peak or a larger area. We will only award for a larger area, but not for A, because A must definitely be there, or lower peak, because remember we said now bullet number 1 is going to fall off because of A remains the same. And then Charlotte says at 634, I don't agree with the new memo. They asked about A and B. Shouldn't the memo be given marks for where A and B is? That is what we basically corrected, Charlotte. Thank you very much for your inputs. Colleagues, let's go to question 7. Sorry, colleagues. Now at question 7, consider the balanced chemical equation below that takes place in a sealed 3 decimeter cube container at 300 kelvins. The equilibrium constant of this reaction is equals to 0.56. AB gas plus 2C, 2 gas gives us now AC4B gas. At 7.1, define the term closed system. A system that is isolated from the surroundings, or a system where substances cannot leave or escape the container, 2 or 0. Let me just get my pen right. 2 or 0, colleagues. 7.2, the amount of each substance present in the equilibrium mixture at 300 kelvins are shown below. AB 9,125, C2 2,2, and that Taizani kindly mute. AC4BX. So in the Afrikaans, colleagues, it was AB was written as 9,125, but it was corrected. I hope it will not cause any problems. It was corrected early in the morning, so we'll definitely be working with 9,125. 721, the molecular mass of AB is 28 grams per mole. Calculate the initial mass of AB used in this reaction at 300 kelvins for 9 marks. The learner can use the option of using the number of moles. So the marking criteria here, colleagues, I'm going to assign A, B, and C quickly. Let's make this one A, this one B for the correct expression, this one C, this one D, and this one E, and this one F, and this one G, and this one H, and this one I. Divide the equilibrium moles by volume, the correct Kc expression, substitution of Kc value into the correct Kc expression. The number of moles of AC4B change is equals to the number of moles of AC4B at equilibrium. The use of now mole ratio of NAB is now equals to 1:1. The other mark for G will be now at N of AB initial is equals to N of AB equilibrium plus NAB change. And the substitution now of the 28 into the N is equals to M over M. Let's get into option 1. Let's try to find A, colleagues. A will be for dividing by A. That means now this mark should actually be dividing X by 3. That means the equilibrium moles by 3. Criteria number 2 will say let me just have my notes here with me. It will say now correct Kc expression. That will be B. 1 mark. And then the substitution of Kc value into the correct expression, that will be now C. And then substitution of equilibrium concentrations. So these concentrations that are there at the bottom are now correctly substituted. That will be now D. And then we go now to the table where it says N of AC4B change is equals to N AC4B at equilibrium. So this is this mark here, colleagues, where we confirm that actually this is now the correct one. Sorry, colleagues, about that. We just go quickly there. Just moved it by mistake. Yeah, here, colleagues. And let me zoom in a bit. Thank you. Then that will be E. And then using the mole ratio to indicate that the number of moles of AB, that is now this mark here, to say they are equal that mark of the ratio. Then the other mark is for saying NAB initial is equals to NAB at equilibrium plus NAB of the change. This is now this mark here, colleagues, of getting the 12. So this mark here is our F. Sorry, that will be G. This will be now G. Then we move, colleagues, into the substitution of 28. Then we go to this, the substitution of 28. That will be GH. That will be the H now there. And then the final answer will be the I. So what does that say? That says now if we have a wrong Kc expression, it will be 6/9. Then if no Kc expression followed by correct substitutions, it will be 8/9. So for you to make it easy, it's always best to have your A, B, C, D, E, F, just to have a sequence of you now marking this particular question. Let's check if the learner now decides to use concentrations. We have a criteria also for that. We must also assign A, B, C, D for that. So we'll still assign A, B, C, D, E, F, G, H, and I for the purpose of marking, colleagues. So A will be dividing the equilibrium moles by 3. How do we know that it has been divided by 3? By the actual fact of having the equilibrium concentration being 3,042, 0,75, 0,98. So that mark is this mark here of A. It's this mark here, colleagues, of A. The correct Hayes expression, B. The substitution, C. And now substitution of the correct concentrations, that will be now D. And immediately thereafter, we go back now into the table. What do? We check if the concentration of change of AB is equals to the change concentration of AC4B. So for us to do that, we award now that mark. Then using the mole ratio, we spoke about that. And this one now of concentration of AB initial is equals to the concentration of AB equilibrium plus the concentration of AB change. So we are only working with AB, then that will be that mark that will give us the 4. So this will be at F. Then we have the other one now where we say we are working with concentration. So be on the lookout that we don't award a mark, colleagues, for CAB is equals to N over V. We only award a mark for the actual substitution of 28 in the marking criteria. So we are going to give this one H as a mark and then I for the final answer. But colleagues, also note that we have range, like we did say, the range there will be now from the range will be from 335,98 to 336 grams. And that is how we are going to mark our calculation at 7.2. It just wanted now our learners to actually understand steps and approach to this particular questions. Ladies and gentlemen, let's go now to 7.22. At 7.22, it says now a catalyst is added. How will this affect the equilibrium constant? Choose from increase, decrease, or no effect. The correct answer is no effect, because now only temperature affects the value of the equilibrium constant. Colleagues, let me just do this. Okay, done. Thank you. Looks like I lost Mebusi, so she wanted to rejoin the meeting. 7.23, explain the answer to the question. 7.22. Only temperature affects the value of the equilibrium constant, 1 mark. 7.3, the temperature of the container is now increased to 320 kelvins. When a new equilibrium is established, it is found that now 4 mole of AC4B is present in the container. Is the forward reaction exothermic or endothermic? The correct answer there, colleagues, is endothermic. Use the Le Chatelier's principle to explain your answer in 731. So to explain your answer in 371, basically we say now which factor was actually changed. So these learners of ours, colleagues, had to understand that now at equilibrium, it was found that at increased temperature, that we have now 4 mole of AC4B. But when we go back now to the number of moles in the table, colleagues, that was now another hint given at equilibrium. This number of moles, it was now 0, or this is concentration, sorry. It was given as something like 2,8. Let me just go up, 2,875. So there was actual increase in the amount or the number of moles of AC4B when we increased the temperature. So we basically now did what? Favored now the forward reaction by increasing the temperature. So the hint was they must now refer to the mistake maybe or to the question of the initial number of moles in 7.2. So the fact that now there was an increase in the number of moles of AC4B, it means now this reaction was endothermic, and the reason for that is increase in temperature favors an endothermic reaction. The forward reaction is favored. We will also accept if the learner says now the concentration of products increases or the concentration of reactants decreases. Then check, colleagues, for the learner just to say now forward reaction is endothermic or just endothermic, we will award also a mark for that. That is now at 7,332. So the hint was given as in the calculation at 7.21. 733, it says now how will the equilibrium constant change when the temperature is increased to 320 kelvins? Choose increase, decrease, or no effect. Colleagues, because now the forward reaction is favored, that means now more products will be formed. Then it means the Kc expression, the Kc value or the equilibrium constant will also increase. 7.4, more of C2 gas is added to the reaction mixture at 320 kelvins. How will each of the following be affected? Choose from increase, decrease, or remain the same. 741, the correct answer is decrease. 742, the correct answer is increase. 7.5, it says now the pressure is increased by decreasing the volume. How will this change affect the following? Choose increases, decreases, or remains the same. 751 increases is the correct answer. And then 752 its increases is the correct answer. We'll probably apply negative marking on this one because it says now explain your answer. Increase is basically now the application of the Le Chatelier's principle again, colleagues. But now the factor that is being changed, or the disturbing factor, is now pressure. Why? Because the pressure is increased by decreasing the volume. So it basically says increase in pressure favors the reaction with less number of moles of a gas. Then the forward reaction is favored. Then that will be now your 2 marks. I think, colleagues, we should now apply negative marking, but we'll take now other general inputs or comments relating to question 7. And the total of question 7, colleagues, is 24 marks. Let me quickly check in the chat because I don't see any hands as yet. Let me quickly just check. In content manuals received from the DBE, the definition for 7.1, let's go to 7.1, Marisa, 7.1. It says 7.1 is different. Closed system is one that only changes energy with its surroundings, not matter. Marisa, we will accept that as per definitions of DBE also. I think so. It is a system. The closed system is one that exchanges energy with its surroundings, but not water. I think we will accept. We'll look into it also. And then there's Joy Kruon. If the learner wrote a catalyst only affects the activation energy, is it acceptable? That is now at 7.22. 722, a catalyst is added. How will this affect the equilibrium? Explain the answer in 7.22. Catalyst only affects the activation energy. I think we can accept Joy. I think so. I think we can accept, but maybe we'll add more body into it. Charlotte is now saying, can we accept a catalyst only affects the rate, not the equilibrium position or equilibrium constant? More or less the same as this one, Joy, Charlotte. I also think we should accept, but maybe we'll add more into it. That is all I have from the chat. Let me quickly now mute Ntaten Hlapo. Who is this? It's not Ntaten Hlapo. Colleagues, kindly switch off your mic so that we can be able to hear others. Ntate Lefera.
Ntate Nambane, thank you.
Yes, sir.
Yes, Ntate Nambane, but there's also a voice somewhere. You can. My question
also
is
try to look for it. Colleagues, let's just mute so that the speaker on the platform can be audible for everyone. But it is here within that Hlapo. Let's mute that Hlapo. Ntate Lefera, you can go ahead.
Okay, my question is based on 3.3. Sorry, 7.3. I'm sorry.
3. Oh,
7.3.
okay.
Yes, 7.3. Now, the question is, the temperature of the container is now increased to 320 Kelvin, When a new equilibrium is established, it is found that 4 moles of AC4B is present in the container. Then it continues saying, is the forward reaction exothermic or endothermic? Now, let us say, therefore, now from 7.2.1, a learner did calculations, and then maybe a learner had that idea, had that hint in mind. Okay, I must go back and then check that answer there. But now the answer happens to be bigger than 4. Let's say the answer happens to be 5 instead.
We will not accept Ntate.
Okay.
Thank you, sir. Only because of the calculations thereof at the top should somehow be correct for us to be able to consider 731. So basically, they are losing the marks there. They will also lose the marks here as well. Thank you very much. So we will not accept. Any inputs, colleagues? If there are no inputs, let me give Mebusi maybe to wrap up question 7. If you have anything to say, Mebusi, on question 7.
Thank you, colleagues. 723. Let us accept if learners explain in terms of catalyst. But when discussing the questions now, or the answers with the learners, let us emphasize to the learners that they need to answer in terms of the question is based on the catalyst, equilibrium constant. Will it affect the equilibrium constant? So it is important to answer in terms of equilibrium constant, but let us accept if they answer in terms of a catalyst, but that answer should be correct, as the two colleagues have given the answers. Now, in question 7.2.1, Mr. Nambane, can you go to option 1?
7.2.1. Option 1. And number of moles.
The table. I need the table, yes.
This one here.
The bracket actually has shifted. The bracket should include the change in moles and the equilibrium moles. And then the addition of the 2 must give us the initial mole. So the arrow should point to the initial mole, and the bracket should be between the change and the equilibrium mole. So there was a shift.
Noted.
So
maybe there's a request that, there's just a request that you raise your voice a little bit. They cannot hear you.
Apologies for that, colleagues. I hope you actually captured what I said earlier. I just said in 723, let us accept if learners answer in terms of catalyst. But when we discuss with the learners, let us tell the learners that the question is about how it affects the equilibrium constant. So their answer must be about the equilibrium constant. So, but it's fine when we accept, let us accept the answer in terms of a catalyst. But when we give feedback, let us just tell them how to answer completely, even if they include the catalyst, but and also include the equilibrium constant, what affects the equilibrium constant. Now, in terms of option 1, Mr. Nambane will just rectify that one, the arrow and the bracket. So that will be fine. Now, just scroll a little bit down there on option 1. I just want to see the part of C of 6/9. Wrong Kc expression, maximum 6 out of 9. Colleagues, the 6 out of 9 comes in terms of, in other words, if the Kc expression is incorrect, the learner must lose a mark for the Kc expression, which is the first mark, and then must lose a mark for the substitution of the case of the concentrations, because now the Kc expression is wrong. We don't give the mark for the substitution of the concentration, but we still give a mark for the Kc expression, the substitution of the Kc value, So the learner will lose the mark for the KC expression, will lose the mark for the substitution of the concentration, and will lose the final mark. Hence, the maximum will be 6 out of 9. And then with no KC expression, remember everything will still be correct in terms of substitutions must still be correct. So the learner will only forfeit the mark of the KC expression that is not there. Thank you, colleagues.
Thank you very much, Mebusi. I don't see any hands. I don't see comments in the chat. So it basically says, colleagues, we can go to question 8. In question 8, colleagues, the graph below shows the number of moles of all species in a closed system. The balanced reversible reaction is given. XCl5 gas gives us now XCl3 plus Cl2 gas. And the graph is given there, colleagues. And at 8.1, define the term reversible reaction. A reversible reaction, a reaction is reversible when products can be converted back to the reactants. So obviously also 2 or 0 colleagues. 8.2, how much time was required for the system to reach the equilibrium for the first time? It's 10 seconds. At 8.3, how does the rate of the forward reaction compare to the rate of the reverse reaction at the following times? Choose greater than, smaller than, or equals to. Then 831 greater than, 832 equals to, 833 smaller than. And then at 8.4, it says now 30 seconds after the start of the reaction, 0.01 mole of Cl2 is added to the system. How will this change affect the amount of XCl3? At 8.41, it will decrease. And then use the Le Chatelier's principle to explain the answer in question 841. Increase in the Cl, or the concentration or the number of moles of Cl, favors the reaction that uses the added Cl. Then the reverse reaction is favored, or the concentration of Cl2 and XCl3 decreases, and that will be your 2 marks. And the question, or the total marks for question 8, it is 9 marks, and the total of this paper, colleagues, will be 150. Colleagues, with that being said, from me to you, thank you very much. We will take now inputs, comments, anything that relates now to question 8 before we can maybe go back to that one of Ntate Mokoena in question 2. Inputs, comments, colleagues. Let me see. Chavalala MP, Tshepang.
Nambane, dumela.
Dumela Ntate.
I also have 2 questions that I want to ask based on question 2.5.3.
Let me go to question 2 then.
2.5.3.
2.5.3. 2.5. Yes, sir. What about?
Yeah, in terms of the product of esterification, that ester. So Elena here wrote the condensed structure as CH3, COO, CH2, CH2, and CH3.
There's a wait, 1, 2, 3, CH2, CH2. Let me just write it for other colleagues also to follow. Just give me some time. This will be another CH2 and then another CH3. So it's CH3, COO, and then CH2, CH2, CH3. Yes, sir?
Yes, yes, ma'am.
We will award a mark, sir. It is correct. It's just that the learner just started with the part of the carboxylic acid.
Okay, ma'am.
Yes.
Can I go to the next one? Right?
Yes, no problem, sir.
Okay, there's also one in 3.4.1.
3.4.1, 3.4.1. Yes, this one.
Yeah, where the learner had to give the condensed structure also. So it says here CH3, CH, CH2, CH3. But over that carbon of CH, there is one covalent bond.
Let's start it again so that I can also just capture it here for purpose of reference. It's CH3.
CH. CH2.
CH2. CH3.
Then over that carbon of CH, carbon number 2, there is a covalent bond and CH3.
Something like that.
Yes.
Yes, we can accept the reason for that is at least the bond that is indicated is between carbon. It's not between the hydrogens. We will definitely accept for 2 marks.
Okay, thank you.
Yeah, thank you very much. Any other questions, colleagues? Inputs? Wait to the examiner, the quality assurer, nothing. Colleagues. Maybe we see colleagues don't want to say anything. So from me to you, colleagues, kindly complete the register. Inform those that are not part of this particular meeting that the recording is basically available now as we speak on our YouTube channel. And from me to you, thank you very much for all the inputs. Thank you very much for the dedication and the hard work that you put in. All the best for the winter school that is coming, winter classes. Thank you very much. And Mebusi, the platform is now yours. Thank you very much, colleagues.
Nambane, thank you very much. Are you telling me that we are done with question 8?
Yes, Mebusi.
Okay, then. Let us go back to the general comments. There was a question that you asked about the general comments, or was it the one from Tepang? The colleague
it was
who
from
wanted something.
Yes.
Okay. I also received a question now about question 6.1. The question, yes, the question was, do we accept if Elena says change in concentration of reactants and products per unit time? Remember, colleagues, the learner does not have to mention all these. Oh, sorry, I might be too low. Remember, in 6.1, colleagues, the learner does not have to mention all of them. The learner can say change in concentration per unit time or change in amount per unit time. It does not, the learner does not have to mention all of them. So if a learner, the question was, if a learner says change in concentration of reactants or products per unit time, is it correct? Yes, it's perfectly correct. Learner just needs to mention one of them, but the change part is very important. It must be shown. Thank you. If there are no other questions, colleagues, all the best with the marking, and thank you very much for your contributions. They actually helped us a lot. And colleagues, I hope everybody was listening as people, as teachers, the colleagues were asking questions, interpreting the questions, etc. And please let us use that as an eye-opener, colleagues, when we set our questions. It's definitely an eye-opener for us as well when we set our questions. But let us also use that as an eye-opener for us, colleagues, when we are at schools, in terms of how we need to ask questions, how clear they need to be. And that, Mr. Nambane, I think shows that our colleagues are actually interpreting questions as learners would interpret them. So I actually believe that colleagues are capable of setting quality questions as well, or quality tasks as well. And thank you very much for that, colleagues. And I believe now, slowly but surely, we are heading towards setting our own common tasks, colleagues, our own exams as well. So that will be taken into consideration for the future, and all the best in terms of marking, colleagues. And please let us ensure that we mark as accurate as possible. And where we need to penalize, let us just penalize now so that learners don't repeat those mistakes for the coming exams and for the November exam. Let's not just correct where the learner made the mistakes and give full marks. If there's a mistake, obviously the learner must be penalized. But from Mr. Nambane and I and all my colleagues, subject advisor colleagues, thank you very much for your contributions. And if there's anything more that you find as you mark, ensure that you just take a snapshot and send to your subject advisor, and then we will discuss and come up with possible solutions. Thank you very much, colleagues. Have a good day.
Thank you very much, Memo. We see there's one more hand from Mokwena FD, and then we'll immediately close this meeting after that. Mokwena FD. Mokwena FD.
Don't forget to unmute.
Mr. Nambane.
Yes, sir.
Yes, Mr. Nambane, question 2.5.3.
2.5.3.
Yes, in that question 2.5.3.
2.5.
Can you hear me?
Yes, sir. Yes, we can hear you clearly, sir.
Yes, question 2.5.3. Then if the child has used structural formulae instead of condensed structural formulae and has used them correctly, we take all the we penalize somehow.
Here, everything is correct, but now the learner used structural form.
Structural form. Yes, everything is correct.
And obviously they will get 1 mark for the water, because it's also correct.
Yes.
Now the question should now come into the organic molecules.
Yeah.
Mebusi, structural formula used for alcohol, carboxylic acid, and the ester.
I have an answer for that, what we do at the end of the year, but I'm tempted to ask colleagues, other colleagues in the group, how would you mark that one? What do you think we need to do? Take all the marks, just suggestions from you colleagues. Take all the marks for using structural formula because the learner did not actually answer the question according to instructions. What do you think we need to do now, colleagues, in June, so that the learner does not repeat that mistake? Before I give you my opinion.
Maybe I should just say, Ntate Mokoena, what will be your suggestion on that while you are on the floor, Minia?
Yeah, I think we can just penalize the learner, maybe 1 mark.
1 mark.
Yes, three out of 4.
Yeah, 3 out of 4.
Yes, because everything is correct. It's that he or she did not adhere to the instruction.
So 3 over 4 is suggestion number 1. Any other input, colleagues? The learner now drew the structural formula or use structural formulae instead of now the condensed structural formula. Any other one, colleagues? You can just unmute and say something. Thank you very much, Ntate Mokoena. We'll wait for the answers from colleagues as we deliberate more into this one. Any other one, colleagues, that can maybe add something here? Please feel free to do so. Just unmute and say your inputs. Let me start with Ms. Selina Mofuke Mfaladi. Mfukeng.
Nambane, I think we should penalize the learner. We should make sure that they understand the difference between structural formula and a condensed structure. We should give the learner 1 mark for water.
1 mark for water, so 1 over 4. Ntate Taitsani, noted. Thank you very much for your inputs. Ntate Taitsani.
I agree with the ma'am who just mentioned 1 out of 4 here, because he wanted to see whether a learner is able to draw a condensed structure for those organic molecules that are indicated there in the question. Thank you, Ndate. 1 out of 4.
Thank you very much, Ndate Taitsani. Mevusi, kindly close it for us as how we'll mark it now in the final exam.
Thank you, Ndate Nambane. I was going to say something else, but based on what colleagues have said, let's not be lenient. I think out of the 3 colleagues, 2 said, let's give 1 out of 4. So let's go with the majority in this case and give 1 out of 4 because we want to correct the mistakes most colleagues there. So for now, let us penalize, and then at the end of the year, we'll only penalize once. But for now, let us penalize for all of them. Thank you, colleagues.
So it will be 1 over 4. Thank you very much. Marematlo, inputs, please. Marematlo. Maremato, we cannot hear you. Maybe you are unmuted, but now we are not hearing anything from your side. While we are at it, maybe we should allow that Sarome gently, or Maremato, you are here. We cannot hear anything, Maremato, and that is Sarome. Maybe jump in quickly while Maremato they are sorting their mic.
fine, Mr. Nambane. Thank you, Mr. Nambane. I'm fine now.
Oh, you are fine. Thank you very much. Marimatlo, you are the only one left, and then we'll be able to close this particular.
Mr. Nambane, can you hear me now?
I can hear you fully.
You can hear me. Thank you.
Yes,
Mr. Nambane, mine is on question 7.
Question 7.
7.3.1 and 7.3.2 regarding the marker notation. If you look at 7.3.1, it says, is the forward reaction exothermic or endothermic? And the answer is endothermic for the forward reaction. And when you look at the mark allocation for 7.3.2, the last mark there repeats 7.3.1. Can we adjust that?
Okay, bullet number 3, ne?
Yeah, the last one.
Okay, can I just say, let's wait for the addendum. I saw it while explaining, but I want to discuss it further with the moderator.
All right, that is fine. It is in order. Thank you.
Yes. Thank you very much, sir. Colleagues, from me to you, thank you very much and have a lovely day.